right, so the second part of this lesson is geometric series. So again, the difference between a sequence and a series is a sequence is just a list of terms separated by a comma, but what a series does is it takes all those terms and it adds them all together. So we learned in the first lesson, like 8.1, that you can just plug in every single number into the rule and then add them all together, and that's your answer. But for arithmetic and geometric series, there are shortcuts. So we learned the arithmetic one in 8.2. This is your shortcut for a geometric one. So in this case, where there are only 5 terms, you can plug in and just add them together, and it doesn't take a lot of time. But if there were 20 or 25 or 30 terms, you would definitely want to use the shortcut. So there are 3 things that you need to know for the shortcut. You need to know the first term. So every time we need to ask ourselves, what's the first term? We need to know the common ratio. And we need to know how many terms there are. So those 3 things we need to know every single time. So let's look at this first example. If you're not sure what the common ratio is, it's always the thing being raised to the exponent. So it's our base. So in this case, our common ratio is 4. To find the first term, we just plug in a 1 into the formula. So if I plug in a 1, 1 minus 1 is 0, and 4 to the 0 power is 1. Anything to the 0 power is 1. So our first term is 1. All right, and then we also need to know how many terms there are. And we go from 1 to 5, so that means there are 5 terms. All right, once you know your first term, your common ratio, and how many terms there are, we're ready to plug it into this formula. So our first term was 1. Our common ratio is 4. So 4 to the 5th power. And on bottom, we have 1 minus 4, common ratio again. All right, so in the numerator, we have 1 minus 4 to the 5th power. So I'm going to do some math, and then we'll check out what we've got. Okay, so when I take 4 to the 5th power, I get 1,024. And so on top, I have 1 minus 1,024, which is negative 1,023. And on bottom, I have 1 minus 4, which is negative 3. And then don't forget, we've got this out front. It's just a 1, though, so it's not going to change our answer. So when I take negative 1,023 divided by negative 3, the answer I get is positive 341. So if I plugged in 1, and then plugged in 2, plugged in 3, plugged in 4, plugged in 5, found all 5 of those answers, and then added them together, the answer would be 341. All right, we've got a new example. We know it's a series because of this capital sigma. And there are 3 things we need. We need the first term, the common ratio, and the number of terms. Common ratio is pretty easy. It's whatever your base is. In this case, our base is 2 because that's what has the exponent. So our common ratio is 2. The number of terms is pretty easy. We just look, we're going from 1 to 8, so that means we're plugging in 8 different terms. And then to figure out what the first term is, you just plug in a 1. So if I plug in a 1 for the variable, 1 minus 1 is 0. 2 to the 0 power is just 1. And then we take 3 times 1, which is 3. Shortcut, the first term is always going to be this front number if there is one. All right, so now we've got the 3 things we need. Now we can plug it into this formula. So we've got the first term comes first, and it's 3. And then in the numerator, we have 1 minus r to the nth power. And on bottom, we have 1 minus r. So we have 1 minus 2 to the 8th over 1 minus 2. All right, so we get 2 to the 8th power is 256. So now when we simplify this even more, we have negative 255 divided by negative 1. And then, which is obviously 255, then we're going to multiply that by the first term, which is 3. So our answer is 765. So if we add all 8 of those terms together, we get 765. Okay, we're going to do 2 more of those examples together. And the way we know that this is a geometric series as opposed to an arithmetic series is because of this exponential power right there. If we have an exponential function, an exponential rule, which is what makes it a geometric series. If it looked linear, then it means it would be arithmetic. All right, so we need to look for our three things: our first term, our common ratio, and how many terms there are. Our first term, if we plug in a 1 for k, we end up with 4. Our common ratio is 3. It's whatever has the exponent. And the number of terms, we're going from 1 to 4, so there are 4 terms. All right, we plug all of that in. So our first term is 4. 1 minus r to the nth power, and 1 minus r. So this time, I know what 3 to the 4th is. That's 81. So we have 1 minus 81 over 1 minus 3. So we get negative 80 over negative 2. So 40. 4 times 40, 160. So if we add those 4 terms together, plug in each one, and add them together, we get 160. All right, one last example. Again, it's a geometric series because of the sigma, geometric because it's exponential. Our first term is negative 2. So that's what you get if you plug in a 1. Our common ratio is 1/2. We know that because that's what's being raised to that exponent. And the number of terms is 6. We're going from 1 to 6, so there are 6 terms. Once you have those 3 things, you're good to start plugging it into the formula. So the sum is the first term times 1 minus r to the n over 1 minus r. All right, so this one's going to get just a little bit messy here. So we've got negative 2 out front. 1/2 to the 6th power. Let's see, that would be 1 over 64 divided by 1 minus 1/2. So let's see, 1 minus 164, I'm going to need some space. That's just 63/64. Yeah, you can still see me. Divided by 1 minus 1/2 is 1/2. Well, this is really messy to have a fraction divided by a fraction. And that's why in math, when we divide by a fraction, instead we keep it, change it, flip it. So we have 63 over 64 times 2 over 1. So let's see, we get 126 over 64. I'm going to simplify that just a little bit. Let's see, we can divide by 2 and get 63. Over 32. But then don't forget to multiply by this negative 2. So we have negative 2 times 63 over 32. So negative 126 over 32. Now, real messy. We can reduce that again to get negative 63 over 16. And that's as far as it can reduce. So we'll leave that as our final answer.